Logic restructuring is a method used to modify the RTL during synthesis for optimization. It essentially restructures the logic codes to decrease switching activity and thereby reduce dynamic power consumption. It reorders the codes by shifting those with high switching activity up or moving the high toggling logic towards the input, and by shifting codes with low switching activity down or moving the low toggling logic towards the output. Logic restructuring does not affect the circuit's functionality and helps minimize dynamic power. The challenges in logic restructuring include that the restructuring occurs during the synthesis stage, so the tool's performance determines the logic restructuring effectiveness. Additionally, it does not much improve timing or area, and restructuring the design might introduce bugs that cause verification problems in the gate-level netlist. The solutions to the challenges mainly involve logic restructuring, which aims to reduce dynamic power. It is also beneficial to use power-aware tools to verify that the restructuring should not cause any power-related issues. Techniques like pipelining and retiming can be combined to improve timing and area efficiency. Additionally, performing static and formal verification checks helps identify bugs introduced by logic restructuring. Some benefits of logic restructuring are that it greatly reduces dynamic power and maintains functionality after restructuring, thus preserving logic equivalence before and after the process. Here is an example of logic restructuring discussed with a Verilog code. The code before logic restructuring assigns the variable y as the OR of A and B, C and D. The first waveform shows the inputs, and the second waveform shows the output y before restructuring. The code after logic restructuring creates intermediate wires A, B, and C, D that store the values generated by the AND operations, and then the output y is determined from those intermediate values. The intermediate outputs are shown in the third waveform, and the output y after logic restructuring is shown in the fourth waveform. The output waveform y looks the same before and after logic restructuring. The two outputs are the same because the functionality remains the same before and after logic restructuring. However, it is necessary to understand a few points. Logic restructuring produces the same output, but the restructured design shows the intermediate data, which assists the tools for power analysis more accurately, and it also helps to split the high and low toggling logic.